Guys, just wanted to welcome everybody. Thanks for joining us today. And this is Mr. Bag. He's going to be presenting today and giving us his insight and his extensive research on the sandwich belt handle conveyor for open pit or open cast mining. He's currently working on a project with Donnie there that hopefully we'll be able to eke our way into and get a system installed for them. But he's done a lot of research. He's done a lot of speaking on this subject. So it's nice to have someone else speak on it besides us, someone else that has bought in and understands the benefit of it. And so I'm going to let him give his presentation. And then if you guys have questions, then I'll let him just manage the meeting, whichever way is best for him. Go ahead. Let me know if you need help with sharing the screen, but you should have access to it.
No, actually, I have made the presentation with a lot of introductions also. Not that directly I have come to Dhiroli. It is not like that. Because the idea, it has to be conceptualized. People must understand what is it. So I have gone step by step. But even then, the initial slides are also highly valuable. Because you know, there is no reference of application of high angle conveyor in open cast mining. So it is very important to understand the mining and how we will apply. And then shiftable conveyor is coming. So entire presentation, it is almost 70 slides are there. I have put all my efforts to put it here. Some videos are also there. Very interesting. So I think that, you know, the other representatives, I do not know whether they are going to join or not. Otherwise, we can start. Or afterwards also you can circulate. No problem. Shall I start then?
I think Mr. Bag, please go ahead.
Oh, let me share my screen.
Isn't technology great? Look at this, how this is.
Can
you see the screen, my screen?
Yes.
Yeah.
Okay.
Okay. Yeah, okay.
Is it visible?
Yes.
Is it visible?
Yes.
And I am also audible. Okay.
Yes.
So I think let us start the show.
Sure, go ahead.
So it is the opening. Now, here actually I have shown a screen. Actually, you know, this is a chromite mines, Balasore chromite mines. Chromite mines, you know, it is a very, you know, the vertical lenses are there. So you see how the dumpers, they are going, you know, circular way. It is going deeper and deeper. So here in such case, suppose instead of bringing the dumpers, if we put a high angle conveyor from some bench with a crushing arrangement, then of course then such a long route of the dumpers, it can be avoided. So actually, you know, here the high angle conveyor is coming through the total side wall. And you know, if it goes deeper and deeper, there is no problem, because if it goes deeper, then dumper will take more time. More number of dumpers will be there. But whereas high angle conveyor, it will follow the shortest route. So this I have just given an example because I worked on this mine, chromite mines. You see in the pit bottom there are still blastings. I mean the holes are there. So here actually the chromite, it is not in a horizontal deposit, it is a vertical deposit. And after the open cast, then actually we are going through the underground. We are digging a shaft, and through the shaft also we are taking it. So this is, you know, the DSI is this thing. So, you know, we have, it is shown that suppose if it is a pit bottom, then how the high angle conveyor, these are the various benches. And here actually, if you are to discharge, then the dumper will come, it is a diamond crossing, and it will discharge at the tail point. And then actually it will be elevated. So this is the picture which I made for the chromite mines, Balasore chromite mines. You can see this is the, you know, the crusher I put. here are the dumpers are coming, and this is the chromite, this blackish, this is the chromite row. So dumpers are coming. Here is the apron feeder and the crushers, siders are there. It is discharging and it is taken by the bench conveyor. And bench conveyor is discharging onto this high angle conveyor at the tail point. And then the high angle conveyor is taking these things to the surface. This is the concept. Now actually for Dhiroli project, this project which we are working, here the main problem is that there is no outside space to, actually this mine is having two difficulties. One difficulty is that it is a very high stripping ratio, more than 10. So for raising 1 ton of coal, they have to take out 10 cubic meter of overburden. You multiply by 2.5. So much of overburden they have to extract, and there is no space to keep that overburden outside. So automatically entire the overburden has to be dumped as interburden inside this thing. So if it is inside if you are dumping, then there is no space for the haul road. You see, the entire mine has been taken with the internal dump. But normally in other open cast mines, you keep space for the haul road, and both the sides there can be dumped. So here actually we are proposing, these are the various benches and the dumpers are going, and high angle conveyor is taking to the surface, and this is the flank conveyor which is taking the coal to the power plant. This is basically the concept, how a high angle conveyor will be located inside the mine, and naturally when this interburden, it is the OB internal dump, it will proceed each and every year. So automatically high angle conveyor also has to be shifted. So here actually shiftable high angle conveyor is a must, and this shifting, it all depends upon how much mine will progress. Now here the mine will progress at the rate of 150 meter. So obviously the toe of the the interburden is only 100 meter from the high angle conveyor. So obviously there is no other way, but we'll have to find out the way that how this how high angle conveyor can be shifted each and every year. We are coming to that what we have proposed, that we are coming afterwards. But as in short, actually I am telling you, this is the problem, and this is the direction of the mine progress. Now suppose if we put high angle conveyor, then from the surface, how we will look, how it will look? It will look like this. And one of the another essential condition is that through the benches, dumpers will also ply. So we'll have to put high angle conveyor in such a way that is structured. There should be sufficient clearance for the movement of the dumpers. This is another condition. So whenever you are going to align or you are to make the drawing of this conveyor, whatever the structures are there, there should be sufficient space for the dumpers. So naturally, while we are discussing, I asked for what will be the capacity of the dumper and what will be its dimension. Because all the benches are not working benches. There will be some non-working benches, and there will be some working benches through which the dumpers shall move. So whenever the dumper will move, then you will have to put the 100-ton dumper this dimension, and over that there will be some clearance, and over that the high angle conveyor must pass. This is the side wall. So now actually I am just giving you a case study of Kushmunda Opencast project. It is a very big project in India, in Southeastern Coalfield Limited. Southeastern Coalfield Limited. It is something like now 40 to 50 million ton per annum. So you can see these are the various seams, and this is a Kushmunda combined seam. This is the bottom seam. It is a very, very thick seam, something like more than 40 meter. There is another upper Kushmunda seam, and there are other some thin seams. So these are the various benches. So this is your seam cross sections. Now actually I was just talking to you about the Google Earth. So actually I prepared this drawing in AutoCAD 3D Civil, and with the coordinate, and all these things, I can put directly in the Google Earth. And you see the Google Earth, if you place, then you know what is the conditions, what are the lakes and all these things. So what happens, suppose if I put it in the Google Earth, I can measure the distance, because Google Earth will give you X coordinate, Y coordinate, and also Z coordinate. So it is possible to draw the contour, and also without going to that place, without doing the survey, even you can make the measurement and you can make your calculation. That's why Google Earth, in the world, nobody has done this Google Earth, but I have tried. Even I will show you some video how I have done it. It is a highly, the very, very important tool which we can utilize, because all the time it is not possible to go to the place to do the survey, but this will give you the fairly approximation, and we can make some drawing in the AutoCAD, and AutoCAD to directly Google Earth we can place the drawing. So here is an example. This is ultimately mine, and I have placed it in the Google Earth. So this is something extra job I have done. It is something unique. There is no other difference of such work. So this is the final configuration. Let me explain you. So this is the final stage drawing of the mine. So what happens, the haul road, it is going like this, zigzag. So what is the problem? The dumper has to move, and also the in-pit conveyor will also move like this, parallel. So this much of space has to be left inside the mine, so that actually you can make the OB dump here, you can make the OB dump here. Now what happened, this mine, they were supposed to make the in-pit conveyor. They are supposed to install the in-pit conveyor. When I visited there, and this is actually haul road through which the dumper is coming to the surface. Now, unfortunately, they, even they extracted this portion also. So they were stuck up that how to go to the surface. In-pit conveyor has not been installed. They have taken this haul road. So what is the way? Then actually I told you, I will show you this drawing. Then actually I showed that since the high angle conveyor has, your in-pit conveyor has not been installed, so let the dumper comes up to here and let the dumper unload it here, and from here we can take to the surface, say 150-200 meter to this high angle conveyor. And normally otherwise also, when the normal mine is there, then the high angle conveyor also can be located in the side wall. That was my proposition. Now I am showing you. So this is your 10th year stage plan. You see, this is the haul road. This is the external dump. Initially, they are putting the external dump, and ultimately, they are storing the internal dump like this. So this is the internal dump. This is the external dump, and this is the haul road through which both dumper and in-pit conveyor will run. So this is your 10th year stage plan, and this is 15th year stage plan. So it is very important whenever we work on high angle conveyor, it is necessary to ask for the various stage plans and also the bench configurations. Because you have to understand that how the mining is going to be done. Without idea of the mine, how I can propose a high angle conveyor. So this is 15th year stage plan. For Dhiroli also I asked for the stage plans. They provided the stage plans. But in Dhiroli the problem is that here they have put the outside dump. Initially, when the topsoil or the initially excavation is done, then the OB is dumped outside. But for Dhiroli, since the mine block and the colliery block are almost same, there is no space to keep the overburden outside. That is there another constant. And second constant, stripping ratio is very, very high. So mine is very, very critical. So this is 15th year stage plan. And this is final dump. The mine is ended, and these are the benches, and this is the OB dump. This is one external dump, and these are two internal dumps. That is, mine has been splitted into two sectors, left and right. So this is their planning. There is no high angle conveyor planning is there. So actually what I had, now you see, this is the, I made the video how the dumpers are moving.
ये डम और ये डम से इतने ईयर ये मोटामोटी एक साल हो जाएगा, ये मिल जाएगा। तो मान लीजिए 3 किलोमीटर स्ट्राइक लेंथ में आ जाएगा, स्ट्राइक लेंथ में 1.5 में 3 में 4.5 में ऐसा करना स्ट्रक्चर 3.4 ये मेरा बस बेस्ट ऑप्शन।
See the high wall. Now, in the in-pit trussing arrangement, this is the receiving hopper. Sorry. This is the receiving hopper for in-pit trussing. Below that, below this, there is an in-pit conveyor. Now, actually, what I propose, you see that I told you that haul road is not there. So I propose the high angle conveyor. The configuration is there. This was my proposal. This is the platform. The dumper will come. It will. These are the 2, 4, and 5. 5 dumpers can unload in one hopper, and then after unloading, the dumper will come from here. The dumper can enter from here. It will unload here because this is something very high capacities there. So I had to put 3 number of high angle conveyors. So here actually after making the the total drawing, I placed it in this is the original alignment of the in-pit conveyor line. So since in-pit conveyor was not installed, so I gave them the solution that actually this way if we put the high angle conveyor, then it will work. And this is the drawing I made in the AutoCAD drawing. Here the dumper is coming. It is going like this. It is discharging here. So this is one receiving hopper. So five dumpers because the capacity is very high. So if the 5 dumpers can unload at one time, so total capacity is increased. So here is one set, another is one set. So 2 bench conveyors are carrying the coal from here, and here actually with the 2-way chute, I will show you the drawing. 3 high angle conveyors are here. It is coming to the surface. Configuration is something like this. This is the receiving hopper 2. This is the receiving hopper 1, and below the receiving hopper, the conveyor is taking. So it is discharging to this conveyor. Another hopper is also there. This is also discharging to this conveyor, and this is the main bench conveyor. Bench conveyor, it is with a 2-way chute. It is discharging onto 3 high angle conveyors. This my solution was highly appreciated. And this will be the high angle conveyor. This is the top section, bottom section. This is my bench conveyor, and this will be supported in intermediate manner like this. And this was the PFD, process flow diagram. Process flow diagram also I submitted that this will be the the width and all this thing. Each capacity is 4,000 tons per hour. What will be the product size and all this thing. So in fact, this study for the Kushmunda was an ideal case for the high angle conveyor. And actually, I have shown you how dumpers are moving and what we thought, what we offer the solution. Is it clear? Are you getting this point? Drawing and all this thing? Any questions?
I just have
Okay.
one.
Huh?
Yeah, I have one question. Are the 3 side skip angle conveyors working together?
Pardon?
Are the 3 high angle conveyors working together, or they are one
Yeah,
standby?
three high angle conveyor will work together.
Okay. Okay.
It is a Kushmunda. It is a 50 million ton year per project.
Okay. So the capacity is what? 5,000 tons.
It is something I have to check up. Say it is something like 12,000 tons per hour in totality. So each and every high angle conveyor was to handle 4,000 tons per hour each.
Right. Okay.
So this was the solution I had given.
Fine. Fine. Understood.
Now, actually, another project actually I did, it is a Kathara. Kathara, this is one of the main problem with this. This is a very, very old mine. Russians they design. And here the coal seam is dipping more than 35 degrees. That means the whenever the mine is progressing deep. Mine is progressing deep. It is not horizontally, it is progressing. It is another mine is also there, Manipur. That is also ideal. So here I will show you. This is the mine, and actually when I went, actually Director Technical of Central Coalfield Limited, he requested me to visit. And when I visited, then actually this is the eastern side of the mine. It was totally underwater. So it will be dewatered, and this is the slope. And coal has to be taken out to the side slope. You can imagine how difficult it is. This is the haul roads. It is very much disturbed, and it's a very, very steep seam. So this is the configurations of the haul road. So actually, we proposed that there will be, this is one mine, this is another mine, and this is the internal OB dump. So we propose like this. This is the mine. This is the Google Earth. Actually, I am showing you the picture on the Google Earth. So this is the mine. Here from this is the water log. So it will be dewatered and it will be taken by the high angle conveyor. It will come to the surface. This is the existing haul road. And this is the washery. We'll have to bring the coal to the washery. So from this mine, it will come by this high angle conveyor, yellow color, and then there will be a transfer point, and from the transfer point there will be overland conveyor. It will come to the washery. I will show you the video that actually how I made the simulation. And also I propose that there is, there are 3 mines. The extreme mines are being worked, and these 2 mines are abandoned now. So in the same transfer point, even I can put another high angle conveyor, and I can discharge same at the same point, and all the coal can be taken to the washer. And how it will look, suppose at the peak bottom, if we put the in-pit crushers and the high angle conveyor, it will look something like this. This is the high wall, it will look something like this. And this was the economics I calculated. That means existing. Now presently they are working with the dumpers. So the total cost, it is INR in Indian rupees, 90 rupees per ton. And by the high angle conveyor, that is IPC hack is high angle conveyor. This is in-pit crusher and overland conveyor and dumper. There will be also dumper shuttle. This total, it will be 67.03. So this will be my system cost. That is one time system cost per ton, 90 rupees and 67.03. So this much can be the gain for 1 million ton per annum. And I calculated also the discounted cash flow, because there are 2 types of cost. One is system cost. Immediately, that is capital cost and operating cost. What is the cost per ton? And then suppose a mine is working for 20 years. Each and every year, there is a discounted cash flow. That is, money is getting discounted, it is escalated and all these things. So here, the initial investment for the high angle conveyor is this. For existing dumper, there is no initial investment. But actually, this graph is flat and this graph is steep. So at this year, that is 5th year, this will be, economic. And at the end of the 15th year, this will be my total cumulative gain. So actually, it is also very important, because nowadays, while working with the Adani, I am finding they are also confused that how, the economics will be drawn. So at the time, together with, the proposing this thing, you will have to calculate the economics, and you will have to prove that this will be the cheapest. And also, I calculated that what will be net present value and what will be my internal rate of return. Everything I had calculated, and payback period 4.47 years, and discounted cash flow this much of million INR, system 2 this much of investment net profit. So everything, I have got the calculation package, and everything I can calculate. When the graphs also can be calculated, these things, and we can place before the customers. And also I had shown that this is the comparison of OPEX, the system 1 and system 2. And option 1, option 2, option 3, that is capital. That is, suppose if the mine production is increased, here actually I compared for 1 million ton per annum. If it is increased to 1.25 and if it is increased to 1.5 million ton per annum, what will be the gain? Because dumper, if you have to increase the production, then you require more number of dumpers. But with the conveyor, with the increase of the speed, you can have more production. That is the advantage. Now actually I am coming to the present project on which we are working, Dhiroli project. So Dhiroli also, they have not given, but I went to Google Earth and actually I plotted this one. And actually when I brought a cross section, I found this is very much, surface is very much undulating. So this is the mine in the Google Earth. And this is the block area. This is the Dhiroli block area. And you see the mining area is also this. There is no outside staging because you cannot go outside the block. So main problem is that if it is 1:10 your stripping ratio, where they are going to put the dump, there is hardly any space for keeping outside dump. So they are keeping the outside dump in some portion of a mine like this, and they are working like this, and entire internal dump is coming, internal dump is proceeding with the mine progress. So naturally, suppose this side there will be conveyor, and we are proposing, suppose I will show you the stage plan. So, the high angle conveyor also has to be shifted. Now, there are two problems. Whenever it is being shifted, its height, high angle conveyor's height is also increasing. It has to increase because it is dipping. So how to solve it and how I will shift it? So these are the parameters. The annual production is 4 million ton per annum, high strip ratio, multi-seam, deep mine, 9 seams, stripping ratio is 10.55 bank cubic meter. Pit bottom, ultimate pit bottom will be 240 meter. Annual daily working hours, total it will be 5,500 working hours. Then there will be no one advantage that there will be no crushing because here it will be work with a surface miner. Surface miner that cuts coal, there is no drilling and blasting. So you don't have to drill and blast. So in that way, in-pit crusher is avoided. So rate of progress of mine phase, that is in 1 year, the phase shall advance in 140 meters. So 140 meters, if it proceeds, then the seam gradient is something like 3 degrees. That means there will be fall in 7 meters. So high angle conveyor, even if I give, but we will have to solve that in how I will adjust this 7 meters. That is also another critical issue. So anyway, these are the dimensions of, so coal will be taken by this chipper, 35 ton chipper, and its length, width, height, everything they had given when I wanted. And also for 100 ton dumper, also they have given length, width, height, everything they have given. So this was the comment of the Patrick, the Australian. He is saying that customer feels that it is a well-established premise. The high-angle conveyor in the right application is the most efficient way of moving material. What is required is a fundamental understanding of the operation to evaluate the applicability of the method. Basic engineering principles prevail in the application we have at Dhiroli. This is the high strip ratio, multi-sim, deep mine, 9 sims, pit bottom 240 meter. In machine effort, about 22 times the machine effort is required to move OB relative to coal. Obviously, because coal 1 ton OB ratio is much more. So OB is the main thing. OB is the main thing. Even lastly, when I send them an email, I have suggested them that why not they are considering to transport OB also through high angle conveyor. Because for OB only you have to put in-pit crusher. Why you are moving through the dumper? It is a very, very slow moving thing. So actually I have already advised them. I do not know what they will do. So 22 ton of OB to win 1 ton of coal. So this is practically a stone mine. So it should be thought of as an OB mine, not a coal mine. This is Mr. Patrick is writing. Reduce OB cost and efficiency is the very, very dominant factor. In other words, coal movement accounts for only about 4% of mining cost, order of magnitude calculation. In-pit dumping is essential, and the optimized design of the mine to maximize in-pit dumping has already saved 100 crores. Introducing a hack on each flank may impede the shortest haul of OB. Because he wants to understand, suppose if you put a high angle conveyor, whether that will restrict the movement of the dumper or not. So impede shortest haul for OB. Currently, it is planned to run internal haul roads on both flanks in combination with internal bridges to optimize the shortened lead. Blocking this route will increase OB leads significantly. That we had clarified that high angle conveyor will never impede the dumper. Providing for space for a hack, if not relocatable, with reduced in-pit dumping space by about 20%. So hack by increasing lead and reducing in-pit dumping space will increase mining cost by 25% or more. That is 95% of cost will be increased by 25%. Viability is an issue. And then he has given some options. Option A, he has said that please confirm the following or advise. Please confirm that a belt that can pull 270 meter plus for a 150 meter lift is the drawing to scale, has the self weight of 4 belts, the coal and structure being considered. Please include a scale GA 200 millimeter lift as well. Are these belts available in India? What is the foundation size? Please provide details from Dos Santos. What bench width is required? See, blasted benches can carry the load. It is a massive structure considering this IPCC is only this much. Then option B, he has written that relocatable crawler mounted. In fact, we have also advised for the relocatable crawler mounted type of high angle conveyor. So better option for the foundation and belt perspective. Bench width required will need detail. Access roads onto bench will be required to be maintained. Effects, in-pit dumping. What is the feeder travel and crawler arrangement? Please give details of applications since last 5 years. Then option C as B with 55-degree average batter. So the batter is now at 35 degree, the high side wall. But that can be taken as 55 degree. But they have to analyze the stability of the high wall. Because stability of strata is also very important that we cannot comment. Whether in 55 degree, whatever the strata structure is there, that is internal mechanical strength, that we are not. But actually, if instead of 35 degree, if they put the angle to 55 degree, then more space we will get for the mine. So other comments also came. Is it high stripping mine? We are struggling to accommodate OB dump in internal dump. Current design 100 meter space at floor, at toe of internal dump and running bench. Internal dump is moving, say, 100 meter every year. How much space is required for foundation of hack at the floor and movement of dumper? Please give the GA drawing to the scale. How much time required for shifting of hack? Are we loading coal into hack at the floor of the pit or providing loading arrangement at different level space required on each level? So this was their comments. So now actually I am showing the stage plan. You see, this is the third year plan, the mine they are opening here. Now this is the mine boundary. This is the mine boundary and this is my open cast boundary. So practically outside there is no space. One of the critical issue, and what they are doing, they are encroached a portion in the mine and they are putting the external dump here. So third year, this is my bench configuration, and then this is the fifth year. Fifth year it has proceeded like this and it is coming very near to the sidewall. And then 10th year, it has touched the sidewall. So we have proposed that from, and now this is OB. So this red are the mine coal benches and this yellow are the OB benches. So we have proposed, since it has touched the sidewall, so from 10th year we can put high angle conveyor and it can proceed in this way. So this is the 15th year stage plan. You see this is also the outside dump and this is the total inside dump and this is my coal benches. That is, coal mining has been done already. This is become void. It has been filled up with the OB and only this much 100 meter is left and we'll have to manipulate maneuver high angle conveyor within this space. And this is 30th year stage plan. The mine will continue up to 35 years and this portion, they will go for the underground mining. So you can imagine that how critical it is. Criticality is that whenever, say from 150 meter to 250 meter, your length is increasing. Each and every year, the elevation is 7 meter. So we'll have to give a solution of shiftable conveyor, which will be shifted, and also it can adjust this difference, this variation in height. So if we can really solve this problem, we are through. Then it will be something unique. Any mine we can go. It is a very difficult mine for high angle conveyor. It is an ideal mine definitely because there is no outside space. There is no dumper unloading arrangements. But at the same time, moving the high angle conveyor so fast becomes a problem. And at the same time, it is not only the movement, but also we have to take care of the adjustment of the elevation. Now I am coming to the bench plans. Now these are the seams, various seams. Now bench, this is the bench section. So this is the 5th year stage plan. This is the side wall. Now this is the 8th seam. There are 2 seams they are working. One is 8, A and B, top and bottom, and 7, top and bottom. So what I have suggested because both the seams high angle conveyor cannot collect coal. So I suggested them it is better to put the high angle conveyor from this level for 2 reasons. One reason is that when the OB is coming here, now this bench, this coal seam is here. Sorry, coal seam is here. So this high angle conveyor will have more space from the edge of the OB. This is number 1. The height of the high angle conveyor will be also less. So only thing that 8 top and bottom coal will automatically come and discharge onto this high angle conveyor, and from 7 seam through the bench it will ramp up and it will discharge onto the high angle conveyor which has been located in the 8th seam. However, high angle conveyor can be located both at 7th seam or 8th seam. So they had a question. I had suggested it is better to keep high angle conveyor here, and moreover, otherwise also, as totally peak bottom, there may be a problem of the water and all these things. In the rainy season, the water may come. So I have suggested it is better to keep it here. Anyway, that discussions will have to continue. And so this is the 5th year. Now this is 10th year plan. You see here the top configuration is also, it is changing. So this is 590, 560, 530. And these are the wider benches are for the movement of the dumpers for the overburden. So that means these are the working benches and these are the non-working benches. So we'll have to get the support in the non-working benches. We cannot put presence of the support in the working benches. So we'll have to put a configuration in such a way so that whenever the dumper will go, there should be sufficient clearance below the structure. This is 10th year and this is 15th year. This is 15th year and this is 30th year. This solution I had given, I am coming to this afterwards. What I suggested, that instead of one big high angle conveyor, we can put smaller high angle conveyors covering 3 benches. 3 benches. These, so suppose we are keeping one here, then another here, another here. So when the mine is deepened up to this, then another high angle conveyor will come. But otherwise, suppose we can manage with 2, then the third will come. And this movement, and another advantage will be there, you don't have to cut the conveyor. As an unit, it can be shifted. So I'm coming to the solutions what we have given. So this is 30th year stage plan. Now these are all the various here I have put together. All the stage plans. Now shiftable conveyor. So this is the first question. This is the first question, that in which pole seam high angle conveyor that I have already explained, poles shall be extracted from 2 bottom seams, 7 top and bottom located at higher elevation and 7 top and bottom located at lower elevation. The level difference between these 2 seams is 40 meters. Refer bench sections and seam sections. The gradient of seams vary between 3 to 4 degrees. Hack may be installed either at 7 seam or 8 seam or 7 seam. We have advised hack may be installed at 8 seam floor for following reasons. The length of hack shall be less. The distance of edge of internal dump shall be more than 100 meters. Pole from 7 seam shall ramp up and discharge onto receiving hoppers located at 8 seam floor, and 1 bench conveyor shall carry the entire pole. For 150 meters of mine advance per year, the fall in height shall be around 7 meters. Since OB after extraction shall be filled up as internal dump, hence the hack shall have to be shifted annually. Accordingly, solution must cover how to adjust height of 7 meters each and every year. This is most critical issue. So this solution, Joseph, he sent us that, it is a modular sort of things. Phase 1, this is the shiftable conveyor. The DSI GPS will be installed initially at 50 meters net depth as 2 structurally independent modules. That is, there will be a top module, the discharge module, and 1 bottom module. They will be structurally independent. And take-up sections will be the bottom module, and the tail end loading section. The system will be properly installed and aligned. A short conventional conveyor at the discharge end will span between supports at the GPS discharge at the loading frame over the overhead conveyor. That is, whenever it will come at the top, then there will be a separate conveyor which will discharge onto the overhead conveyor. So top drive portion and this conveyor will be an integral part, and bottom part will be another part. These are the 2 parts. Phase 2, after extending 50 meters to 100 meters, this is very interesting. Ahead of the extension, as with the typical advance, conventional connecting conveyor and overland conveyor loading frame will be removed. That is, first I will remove my connections with the overland conveyor, taken to the, and it will be shifted to the second position. Located, the belts will be cut. The head section will be traveled along the end wall as with any typical advance. At the start of the phase 2 location, first there will be intermediate section will come. I will show you the picture. So now, since the difference is there, now he has suggested to put an intermediate section in between top and bottom. So now there will be 3 modules. One is top section, another is second is intermediate section, and third is the bottom section. Its upper end will be connected to and supported from the head section's lower end, and it will be self-supporting at its lower end with all sections installed. The system will be precisely aligned and additional belting will be spliced. So naturally, whenever you are shifting, you have cut the belt. So in the second position within 1 year, again you will have to put the belt and you will have to splice it. That is also a matter of time. With all sections installed, the system will be precisely aligned and additional belting will be spliced at the GPS belts. The extended system will be restarted and put back into productive operation. Throughout the phase 2 operation, the system will continue to advance as required. Similarly to the phase 1 advance, except the head section will have the additional upper intermediate section attached. Then in the third phase 3, after extending 50 meters to 150 meters, because it will go up to 240 meters. At the start of phase 3 location, the second intermediate section. So we put in the second stage the one intermediate section. Then in the third stage, we will put another intermediate section. It will be connected so that the total length will be increased. At its at the part of the phase 3 location, the second intermediate section designated the lower intermediate section be installed. Its lower end will be connected to and supported from tail section at its lower end and self-supporting at the upper end. With all sections installed, the system will be precisely aligned and belting the splice at the GPS belt. The extended system will be restarted and put back into production operation. Throughput of the phase 3 operation, the remainder of the mine life, the system will continue to advance required. Similarly to the phase 2 advance, except the tail section will have the additional lower section attached. Now, crawler type of transport units, what type of crawler? Because Patrick Ellis also wanted a crawler type. Joseph has also recommended crawler type. This transporter unit will consist of twin crawler tracks joined to a common chassis. On the chassis is a bearing with uplift, so it is having some hydraulic jacking arrangement. The lift table will be lifted by 4 hydraulic rams. It will be attached with the structure's pad with the pattern of 4 hydraulic rams oriented square with the structure by cross equalizing the parallel rams. Ram pairs, a hinge will be created perpendicular to the structure. An identical transport unit will be also used at the upper end. So there will be a crawler at the bottom section. There will be a crawler at the top section, and also there will be a crawler at the intermediate section, because the entire thing has to move. So that unit will lift the upper structure to wheel carriage that bears up against inverted rails with ample distance between stops. This will affect and extension support. Additionally, in this case, all 4 hydraulic lift rams will be equalized, creating a ball joint. This will ensure statically determinate support during travel with travel forces totally and easily predictable. For phase 2, relocation and identical transporter unit is added at the upper intermediate section. The transporter unit is arranged identically to the lower unit of the head section with the hinge connection of the head section and the upper intermediate section of travel. Now this is the picture. You see, this is the first stage. This is second stage, and this is third stage. So, and if you see, there are modules. There are the top module with the discharge conveyor to the flank conveyor. So this will move as a whole. This is the bottom section with the crawler. And this is the intermediate section of the crawler. This is a very, very interesting solution. And really, if we are successful, then we'll be through. It is a completely new and innovative things, and many people in India, they are inquiring that how it will be done. So this is one solution, and second solution, in fact, I had suggested this one because, they were expressing doubt how it is possible to, move such a tall structure. So it's very difficult to convince, and then you have to cut the belt, you have to join the belt. So then actually I put another solution. Instead of one single unit, there will be multiple numbers of crawler mounted units which shall cover 3 benches or any other required configuration to suit bench height, and also allowing dumpers to move below the hack structure to adjust the level difference for 150 meter advance. We said this is a very critical issue because this each and every year when it is moving by 7 meter, how we will adjust this 7 meter? That is a very critical issue. Anyway, there are some solutions. So this is Dos Santos, which is already they are having this solution. You see here also the crawler, here also the crawler. So it is covering 3 benches. So we can now this is the conveyor. So this is another high angle conveyor. It will be there. So we can suggest that instead of one stall structure, we can go on covering 3 benches. Okay, and lastly, it is also possible to, the base, adjust for, 12 meter to this thing. So at the bottom section, at the total bottom section, instead of putting one 3 bench structure, we can put this type of structure. This, of course, Joseph is the expert. He can tell whether it will work or not. So these 2 solutions actually, we have offered. No, I do not know. And at the same time, they also wanted the economics. What will be how the economics will be done? That also I will show you that I have already made some cost calculations. So I will show you that. So anyway, so any comment? What is your comment actually? This is a shiftable conveyor. This is something unique which we are considering. Already I have discussed about the fixed high angle conveyor application for Kushmunda. And now actually, the high angle conveyor shiftable type, if we can make the solution, the total world is ours. Because in India, there are so many in the pipeline. So somehow or other we will have to make it successful. And cost part I am coming, that is highly convincing. It will be much more economic. That you will also agree. Even such type of economic comparisons nobody has done. Shall I show you the economic part?
Sure.
Now, what are the critical issues? I have also written down what are the critical issues for the Dhiroli. Critical issues for the Dhiroli is mine boundary and block boundary are very close. So, suppose if they want to bring it by the dumper and unloading at the surface, that will not be possible. Because inadequate space at surface to develop any infrastructure for core unloading arrangement from 35 to 60 ton dumper and feeding to out by conveyor linking power plant, this will require space. How much space? As per my calculation, for unloading arrangement, at least 100 meter by 50 meter platform space shall be required for accommodating unloading hoppers, dumper movement and dumper parking space. Because the dumpers are coming from far away. So one after another, if it comes, it will do the maneuvering and some dumper, otherwise there will be no continuity. In addition, at least then suppose dumper platform is at 10 meter height. So there has to be some ramp. And ramp will be at the, say, gradient of 1 in 15. So if it is 10 meter, that means additional 150 meter space is required for the ramp. And where is the space at the surface? I do not know what they are thinking. But these are the critical issues which I have also mentioned to their planning engineers. System cost will be higher and higher with the mine progress, because more the mine will progress, more and more number dumpers will be there. And diesel price, already it has been increased to 92 rupees in India INR. Nobody can predict that after 10 years what will be the diesel price. So how on the other hand you can compare with a system where the cost is not known? And moreover, global warming and all these things, I do not know how long this dumper and diesel will be allowed. It cannot continue for 30 years. So system cost will be higher and higher with mine progress due to constant increase in number of dumpers, increase in diesel price, less availability of dumpers. Actually, if the distance is increased, availability of dumpers will be also less. We have seen in colliery that morning time when it starts, availability of dumpers is 80%, and at the the afternoon it becomes only 60% or 50%. Many dumpers are under breakdown. Nobody can help it. So an estimated calculation for now, actually I have made an estimated calculation for requirement of dumpers both for OB and coal is enclosed, and I am highly confused that whether so many dumpers shall be able to fly through the benches or not. It requires a national highway. to haul road shall be avoided, because there will be no haul road inside the mine, because there will be totally internal dump. There is no space. So if you have to put a haul road, the huge space will be lost. It requires huge space. So whether they will fill up with the internal OB dump, or they will naturally they are planning for flying the dumpers to the benches. Now you see that I have made the calculations. How many dumpers will be required? So annual production is 4 million ton. Stripping ratio is 10. So annual OB million cubic meter is 40. So annual operating days is 330. So OB or coal to be handled per day, cubic meter or per ton is so much of this thing. Dumper capacity for OB, if it is 100, so 12, a number of dumpers has to fly daily, and definitely with the distance it will further vary. And for coal also it will be 242. So total, if they want to go for total dumper mining, that is a typical, very conventional our dumper mining idea. We have not progressed anything in India. It's all typical, the conventional dumper and all these things are going on. Even we have got the reference for in-pit crushing and Ramagundam and Piparwar. I have worked with the crew, but there is no adoption of that. So high angle conveyor is in that way new concept, but now it is necessary, particularly for this mine. I do not know what solution they will adopt. Is it possible to fly so many 1212, that is 1220 number of dumpers that will fly each day to the dumper?
Bag Sahab, can I have I'll just give you, I'll have a small observation here. You have said that with 100 ton dumpers, you require about 1,200 dumpers to operate. That's what your calculation is, to remove the overburden.
I have divided.
But what you will have to also look at is the cycles that each dumper will do. In how many?
Mr. Haridas, that I know, that cycle time, dumper, and if I calculate cycle time, then more number of dumpers will be required.
May or may not, because what will happen is, otherwise somebody may raise a doubt here. So probably we'll have to put that every dumper runs for 1 hour. I mean, every cycle completes in 1 hour or something.
Mr. Haridas, I will show you in my calculation. Cycle time I know 25 km per hour. If it runs, then it is taking the coal, raising the the benches and coming to the benches, then unloading. It will take much more time. But I have simply estimated if this much of coal or OB has to be handled. So dividing by these things, at least this much number of dumpers will be required.
Okay.
If the cycle time is more number of dumpers will be required. There's no doubt about it, isn't it?
Yeah, because right.
So now actually, I will show you the system cost. Actually, what is system cost? System cost, there are two parts. It's very interesting. I used to teach at Indian School of Mines and IICM. There are two parts of system cost. One is capital cost. The capital cost we calculate because we borrow the capital from bank. So capital cost, it depends upon interest, that is EMI, equated monthly installment, and also depreciation. That is, suppose I have taken some equipment, what is its life? Now dumper, its life is 7 to 10 years. And what are the operating costs? You have to also calculate the power and energy cost, spares cost, labor cost, and another cost which we do not consider, that is breakdown cost. That is the availability cost. Suppose what I mean to say, suppose my capital cost is 10 million rupees annual and my production is 10 million ton. So what will be my capital cost? It is 10 by 10, that is 1. Okay. Now suppose in case of breakdown, if I get 80% availability, then my production will not be 10 million ton, but it will be 10 multiplied by 0.8, that is 8 million ton. So 10 divided by 8, the cost goes up. But generally, while we calculate, we do not consider this breakdown cost. And actually, I have graphically interpolated, that is, suppose 110% efficiency, 11 million ton, the cost becomes 6.21. With 100%, 6.83. Now with this, the availability gets reduced, how the cost is going up. And another thing, suppose if I get this much of less production, then that production, that coal, I won't be able to sell. So availability, we go for sometimes cheaper equipment and we land into the breakdown, or we give standby. That is a totally nonsense idea. Now I will show you the exact software, but this is my the output of the software. System 1, system 2, and system 3 I have calculated. System 1 is in-pit crusher, DSI snake hack from pit bottom to surface and dumper circle at coal face. Because there will be some dumper movement at the coal face which will carry the coal from the coal face to the high angle conveyor. Second is that suppose if we put an in-pit crusher, so in-pit crusher I have already shown you the picture of the Kushmunda, where conveyor, although it can run at 1 in 4, but in any mine in-pit conveyor is not eligible to run in 1 in 4. It has to follow the seam gradient, that is 1 in 15. So whatever may be the gradient for the dumper, conveyor also has to go through that flow gradient. That is one main problem with the in-pit crusher and conveyor. In that way, high angle conveyor is much better solution. And system 3 is dumper transport from coal face to surface and crushing coal at surface. So here are the various input data table. That is, I compared for a 10 million ton per annum capacity of system here, by total annual operating hours. Actually, I have found out the lead distance of dumper one way from coal surface to surface CHP. I have taken it 1.52 lead distance. So all these input parameters I have put it here. Then what is my annual interest rate? Suppose I am taking loan from the bank. What is my annual interest rate? Then what is my annual, each and every year spare parts and all these things, there will be an escalation. What is my annual escalation rate? Life of in-pit crusher, life of conveyor system, life of DSI hack. DSI hack I have taken 16 years for one reason, because structure cost and built-in cost are almost 50-50. Structure lasts for 18 years. And my high angle conveyor, that life is more than the normal conveyor, that is 12 years. So combining these things, I have found out the life of DSI is 16 years, life of dumper 10 years, crushing cost as surface, unit cost per unit. Now it is electrical unit cost. Rate of progress of mine face is 2.50%, and annual discount rate is 10%. Suppose whenever each and discounted cash flow, each and every year, whatever the money I am getting, that will be discounted. Because we'll have to find out the discounted cash flow and the diesel price. So here, actually, this has been derived from the other sheets, that what is my investment here, what is the investment here, what is the investment here. Now, this is the sheet. This is the sheet for high angle conveyor. That is system 1. System 1, I have calculated here. This is, for 10 million ton, we require 2000 millimeter. So lift is 100 meter. Lift is 100 meter. TPH is this much, belt speed, and conveying angle is 35 degree. So if the conveying angle is 35 degree, then sine value is 0.61. So accordingly, by multiplying the length, this hypotenuse length will be 189.70 plus some allowance. So estimated value, I have taken some estimated value from Mark had given me some figure. So from there, actually, I have taken this figure. An exchange rate at that time, it was 75 rupees dollar. So in that way, I have put 10 million ton. Production is here. Annual operating hours is here. And this is my total length. Here from actually it is going here. I require 1 unit. There may be 2 units. There may be 3 units. So if we put 2 units, automatically it will be multiplied. So this is my annual capital cost. And this is my yearly capital cost. Yearly capital cost, there is a formula with the interest and depreciation. I may say, tell you afterwards, show you afterwards. Now, this high angle conveyor, this requires energy cost is 1000 kilowatt, 2 into 500 kilowatt. So 1000 kilowatt power factor is 85%. So it will consume 850 kilowatt. If it consumes 850 kilowatt, 850 multiplied by the annual operating hours, kilowatt hour multiplied by the rate. So this is my total, it is my electric energy cost. Similarly, I have derived, the spares cost and wear parts cost for 1000 hours. So if it is for 1000 hours, then for 5940, I can find out what will be my cost. And labor cost, there will be two kind of labor. One is operating labor, another is maintenance labor. So each and everything I have added here. Now, similarly, the dumper cost, there is in a different sheet, there is a calculation. That is a dumper lead here. Actually, I presume that it will be 1 kilometer because here the dumper lead distance is fixed because dumper is moving only from the coal face to the high angle conveyor. So here is the cost. This I will show you how I have derived this cost. And then in-pit crusher. So in-pit crusher also similarly I have found out the cost. So here actually I have added. So this is my capital cost. And this is also the interest rate, depreciation rate, and this is my annual cost divided by this total production becomes 6.08 rupees. Similarly, energy cost also I have found out that is 5.70. Spares parts cost also I have found out 2.27. So total it is 15.49, and for dumper only it is coming 27.11. So total it becomes 42.60. So in this formula, anything you change, it will automatically be calculated. I will show you my calculator software. It is here. That will be very interesting, and nobody has done by combining these three. So second is that whatever I have done, this cost I have taken the same cost 6.08. Labor cost is 1.44. Energy cost is 5.70, spare parts is 2.27, dumper cost is this. The total is 100%. So capital cost is only 14.3%. Labor cost is 3.4%. And energy cost is 13.5%. But you see that dumper cost is really the biggest cost. And graphically also I have plotted. Then I have calculated for in-pit crusher and conveyor. Here also in a similar way, we have calculated. And so this is for the in-pit crusher and conveyor, and third is the dumper cost, and what I have given, that is for the discounted cash flow, I have taken for the total life of the mine. You see, here the discount rate is 10%, escalation rate is 4%, combined is this much, and 2.5% is the mine progress rate. That is, dumper haul length is increasing. So from there, actually, I have transferred this cost. This is my initial cost. This is energy cost, this is spare cost, this is labor cost, this is total cost. Okay. And at the 10th year, I have put some investment because again I have to invest something. I'll have to investment and replacement cost of dumper, an investment of IPC and DSI, because after 10 years we'll have to replace something. So those costs also I have considered. Thereafter, actually, all these costs, here it has come by multiplying these factors. Multiplying by these factors, this I have found out the total operating cost, and this is the cumulative cost. And in this way, we have compared. This is my system 2, this is system 3, and this is system 1. So system 1 is the high angle conveyor is 42.60. The IPCC is 48.72 and dumper is 88.38 for 10 million ton per annum mine, and mine depth 100 meter. and thereafter I plotted the discounted cash flow. So this is system 1, this is system 2, and this is system 3. And another thing, considering investment made in 01, and this is again a macro where actually I have put the calculation for 100 meter depth, 150 meter depth, 200 meter depth, 300 meter depth, and 400 meter depth. And you see the depth goes up and high angle conveyor becomes cheaper and cheaper. With higher distance, it will be cheaper. So I will, if you want to see, then I can show you the software. By actually going to the software, I can calculate, I can change any figure, it will be automatically calculated. So actually what I have done, I have studied the high angle conveyor application in a mine, that for a fixed position, how it can be done, then what can be the interfaces, that how high angle conveyor will be loaded, that part I have done. I have invented the, the Google Earth. I will show you just now a movie that for Kathara, what I have done. And thirdly, actually, I have also found out, made this calculation package. So that means if anybody wants that what is my economics of our system, that also will be able to tell. Now, only thing it was left, that is the shiftable conveyor. Shiftable conveyor, it was not there. So now actually we are also with the shiftable conveyor is also there. So I would like to show you the,
Now actually we are showing the video on Kathara mine, where currently is being worked. This is the western sector being worked by MDO. This is mine contains seams with very steep gradient and lot of faults. There is a long haul road, and this is the eastern sector part, which is now pit bottom is underwater and shall work by clearing. This is the internal dam between two mines, central and eastern sector. So now we are showing the concept of the in-pit crushing and the high angle conveyor for transporting of coal to surface and then carrying coal through overland conveyor to washery. So this is now coal is being discharged onto high angle conveyor. This is the top belt, and both top and bottom belts are sandwiched and the material is in between. This is, we are showing how the snaking is being done between top and bottom belt to hold the material within the belts. This is the snaking arrangements. And then the coal is taken to the top. And it is being discharged from high angle conveyor onto overland conveyor. And this is the in-pit crusher at the pit bottom. So this is the concept, and this is the proposed layout for Kathara. And this is with the Google, we have drawn the layout. So, we are showing that how it will come from the mine. Here, this is the mine, yellow line, and coming from the mine pit bottom to the yellow line to the pit top. And at this point, there will be transfer hopper, and this is the overland conveyor, which is taking coal to the crushing part of the washery. And the total route length is something like 620 or 30 meters. So this is how high angle conveyor is going, and then through overland conveyor, it is reaching the washery. We have drawn all these things by Google. This is the contour grid also we have plotted. This is how actually the contour is going from the top. This is the water level. Mine will go further 50 to 60 meters below from the present water level. So this is again coming onto the water and again going up. So this we
So here actually I have drawn the contour also. It is possible to draw the contour because Google gives both x-axis, y-axis and also z-axis. So from this file, ALM file, then TCS converter, then through the AutoCAD 3D Civil, we can draw the contour also. So this is the contour lines. Actually, I have drawn the contour lines. You see the sloping part.
we are drawn to plot the contour. This is the all road at the surface. This is the the inclination of the all road, which is very risky. This is the contour we have generated. Now we are showing the present alternative of the dumper transport of the mine.
So this is the contour I have drawn. Now this is another method. Existing dumper. I have simulated the situation.
But I think it will be so much. We have simulated the situation. It will be something like this. So here at the surface, this is the existing all road. The dumpers are moved. The zero line is for the high level conveyor route. And this is the existing all road. This is the point where that is crossing the dumper road. The dumper is going. It is approaching the washery. Now it is entering the washery gate. Then the dumper is carrying coal to the depot. Here the crushing. And this is the elevation level and the total route length of the dumper. Now practically this dumper length will be increased with the increase of the depth. Now this total distance is something like 2.5 kilometers. So what the height is 620 meters, whereas for dumper system it is 2.5 kilometers. So it is almost 1/4. So these are the various economic calculations, evaluations we have done. We have done it in separate report, and this is again another concept we have shown. It is possible to take the coal from the central sector mine also to the same point, and the entire coal can be transported by overland conveyor. So green is hacked from the second mine, and yellow is the hack from the eastern sector mine. So the entire concept has been again taken to Google. So, this is the eastern sector mine. This is the triangle stroke. Thank you.
So almost I have completed my presentation. Now, any question, any comment? In a short time, actually, I have made this presentation. There are a lot of other things also, and particularly the calculation part, it will take some time. But this is a very good software I have prepared, by which any figure I give, it will calculate. So now we are ready with everything. Even I have shown you Google Earth is a very good instrument for us. Without going to a place, we can measure the distance. We can calculate. We can evaluate. Nobody else is having so much of the information. Google Earth will not find any reference all over the world. Even such calculation package is also not there. And particularly, we are waiting only for shiftable conveyor to be successful. Because once shiftable conveyor is successful, there is no point why high angle conveyor will not come to India. And we are fully equipped with this high angle conveyor. Pardon?
Shiftable high angle conveyor.
Yes, shiftable high angle conveyor, because what I have seen, that shiftable conveyor solution we have already given. But to meet the requirement for Dhiroli, it is within 1 year, that is really a very, very critical issue.
Right.
But actually, there are so many places that after 4 to 5 years we have to see. That is not a problem, because already Joseph has given one solution. I have also suggested one bench to bench. So now actually, we have gone one step ahead. And actually, the LinkedIn, after this thing has been given, many people wanted to join this VC. Okay. That means a lot of interest has been generated for this high angle conveyor, how it works. And actually, what is your comment? Whatever I have made this presentation, whether it is having sufficient information or not. But the informations I have given for the different mines and applications, drawing, several things I have provided. So it is not the selling a high angle conveyor, showing a pamphlet. It is really working on the design and going to the mine, showing the things. So we are in a much advanced stage.
Each concept is different. Every concept it's not a repetitive concept. Every project will be a unique project.
Yes. So naturally, you must have conception about the mine planning, because it varies, it differs. Like Dhiroli, it is a typical, Kushmunda, it was a different. And then Kathara is different. But in CMPDI, they have recommended for various projects, because now they are expert in mine planning. And they are in continuous touch, so they have taken a lot of figures from me. They also want a solution on shiftable type of, the high angle conveyor. The shiftable conveyor we did not work so far, but now actually we are working now. Let us see. But I am very sure that shiftable conveyor solution we have found out. But so quickly, this shiftable conveyor, that must be further worked out. And this level difference, for each and every year it is going by 7 meters. So how to cope up with that? That is a matter to be decided. But definitely, so far economics I have shown, but there is no comparison. If it starts from 100 meter and if it goes to 240 meter, you imagine the increase in number of dumpers and the high angle conveyor. There cannot be any comparison. And thirdly, how long diesel will be allowed? If the global warming, diesel cannot run. Already it is 92 rupees. Suppose if I put 92 rupees in my software, the figure will jump. If it is 100 rupees, figure will jump. So anyway,
well, thank you. It was very informative. Does anybody else have any questions for Mr. Bag from his presentation?
Yes, presentation is over. Now, if anybody is having any question, I can answer to that or anything, or we can end it, because already we are discussing for almost an hour, I suppose.
I'll come back to you with any specific application or any specific issue in this regard separately. Well, I think if we keep discussing, this discussion will never end. We can keep going on and on.
No, that's true. That's true. Even I also want the discussions must be go on, because it is not only my head. It is everybody's head together. Because I have evaluated something. I am showing some problem. I am telling my impressions. What are the problems? but I am very comfortable on certain things. That is one calculation. I am very, because if you are very sure this is economic, you can very confidently tell the customer it will be economic. This is one part, and there is no doubt about it. And then efficiency and high angle conveyor, nobody is doubting. Only thing is its application. Application also, there are several case studies we have done. CMPDI also, they are aware of lot of case studies. So that's why they are recommended. Last part is that actually the shiftable conveyor. Now shiftable conveyor, many people are interested. Even through LinkedIn also, I will make a presentation to whoever wants, because this is a confidential presentation for our representative. But once people come to know there is a solution for the shiftable conveyor, so this is good for company. This is good for DSI.
Any other questions?
There would be too much to try to digest just by watching it. All I can say is I'm extremely impressed with how thorough Shyamal has investigated and reported on the whole, all the aspects. There's solid proof there of how it should all pan out. And if that was presented to a customer in South Africa here, they would be exceedingly impressed. That I know for sure. But as has already been said, each project is different, and
Yes.
it's got to be specifically tackled. But I imagine that the principles would remain very much the same. And I also imagine you would come out with similar results.
Derek, what is your suggestion? Actually, it is, I think, whatever the tools we have developed, studies, we can very confidently we can go ahead. We can tell the customers that, and case to case, if we get the case, we can study it. We can convince the customer, whatever the way, how it will be applied, what will be the design. Because unless you come forward with the economic calculations, customers will not come forward, because they must feel confident this will be economic. Suppose if we leave, okay, this is the high angle conveyor, you take it. It will not be so. It itself is a technology. It is a different culture. It is not a dumper culture. It is a different culture. So there will be a shift of the culture from dumper to high angle conveyor. This is a very, very big task. And it is not that easy also. It varies from mine to mine. But actually high angle conveyor, we have seen a lot of applications in surface. But mine, how many times we have discussed. And for the mine, it is the most potential subject. Because mining, why I am telling you, because mining transport cost is 60% of cost.
Yeah.
So where high angle conveyor can play a havoc, and particularly with my calculation package, what I have developed, that is a very, very almost say with 80 to 90% correctness. Because I have from Club product technique we used to together. I tracked, then I went to Eastern Coalfield, Coal India, several data. Even I can find out how much will be the diesel consumption. Even I have not shown you the software. It's a very, very big software. So actually two things is there, that high angle conveyor will run efficiently, there is no doubt about it. It will carry code. Number two, in a mine, we have to show that suppose it is a deep mine, and mine pit bottom is varying from 150 meter to 240 meter. Say here in this case, Dhiroli, 150 meter to 240 meter. And in the calculation I have shown that with the dumper it will be costlier, but with the high angle conveyor it will be cheaper. The cost figure, it will be much less. The difference is much more. Only thing is that where high angle conveyor will be placed, and each and every place, so much of shifting will not be required. It is for this mine, since there is no space to keep the overburden, like say Kushmunda and all these things, we can easily go with the high angle conveyor, which can be shifted after 5 to 6 years. That is not a problem.
Right. And I think you've realized it, you know, and done a great job presenting it as well. Like Derek pointed out, that's a presentation like that is very convincing and very useful when trying to sell that. It's been a challenge for us in India. It always has been. So, you know, if you can corner this one, you will probably, you will have done something that we couldn't do for, 20, 30 years now. So, I think often when we talk about it, it's kind of a no-brainer, but it's just continues to be pushed to the side and ignored and not, there's always some type of question that they'll find a reason to not implement it. And that's just something we got to get around. But I think you've done an awesome job in comparing the two or comparing the options there of what's been used in the past, especially with the haul roads. We watch the haul roads and the danger of them and them trying to do, these autonomous vehicles and things like that, just to get around just something that's simple, a simple option to get out of the pit. And they just continue trying to, do something different with what they're using or think that they're improving on it. And it's just ultimately causing more problems. So yeah, it's just the convincing people of what we all already know. And, but like I said, your presentation is really great. I think it outlines all the major points that we need to make and something we should just keep pushing. I appreciate you doing that. Appreciate your research and your interest in it.
Thank you.
Anybody else?
I'll be in touch with you. Don't worry.
Okay, sure. I'll be very happy to be in touch with you and discuss further. Anybody, if any of you has got any question, any confusion, you can always write to me. I'll be very, because high-angle conveyor is my passion.
I know, sir.
That for the last 10 years I am working with. Haridas, you also know.
Yes.
That without passion, nobody can develop so many things.
That's right.
There is no reference all over the world also. Such calculations, Google are no, I am very sure. So it is my passion, that's why I worked. And I want the things to come. Because we are growing old. Today or tomorrow we will not be there. So we will go up. So I am writing a lot of articles. I am posting a lot of videos. We will let people see, let people educated. But some good technology should come. Good technology should come. So anybody wants any help, I am very free. Actually, you can always refer me, you can ask me. I have got the advantage because I am working for the 10 years. But I have continuously, and I have got special advantage because I have worked with Proof Order Technique, MMD, all these big global giants, and they have got all high regards. So I have worked on in-pit classer, mobile in-pit classer, so I can easily imagine, how it will be done, OB handling and all these things. And mine planning I have done in CMP. So I have done mine planning, I know the material handling, and I know the finance also. That is something rare combination. And Google Earth, this is my special invention. And it is a very, very convenient thing. Without going to a place, without doing the survey, you can estimate, which will help you in making economics. And any customer will be impressed also. Suppose if you show some customer, this is your thing, and only thing in one place it must come. Because there is not much reference of high angle conveyor in opencast mine. We are discussing, but only for surface. What are the reference? We have not discussed on mining application, opencast.
Yeah.
So, thank you, gentlemen. I think I am able to make you happy and give you
Great job.
Informative presentation.
Most definitely.